Welcome to our comprehensive exploration of quality assurance processes and techniques, presented by Dr. Mir Mohammed Asadullah. In this module, we'll delve into the practical aspects of implementing quality assurance in modern software development environments. Quality assurance processes and techniques form the backbone of successful DevOps implementations. These practices ensure that our continuous integration and delivery pipelines maintain high-quality standards while enabling rapid development and deployment. Throughout this session, we'll examine various QA processes, from planning and strategy development to specific testing techniques. We'll explore how these processes integrate with modern development practices and how they contribute to building reliable, high-quality software systems. In this section, we'll examine the core processes and techniques that form the foundation of effective quality assurance in modern software development. These processes have evolved significantly with the adoption of DevOps practices, becoming more automated, integrated, and continuous. Understanding these processes is crucial for anyone involved in software development, whether you're a developer, tester, or project manager. These techniques help ensure that quality is built into our products from the beginning, rather than being an afterthought. As we proceed, you'll learn how these processes work together. Our exploration of quality assurance processes and techniques covers 9 essential areas that form a comprehensive approach to quality management in modern software development environments. We begin with QA planning and strategy development, which sets the foundation for all quality initiatives. From there, we'll examine test planning, execution, and automation, crucial elements in any DevOps pipeline. We'll explore specialized testing types, including performance, usability, and security testing, each playing a vital role in ensuring comprehensive quality coverage. The integration of these processes into continuous integration and continuous delivery pipelines represents the modern approach to quality assurance. Finally, we'll examine risk-based testing approaches that help organizations optimize their testing efforts while managing potential risks effectively. Each of these topics has been carefully selected to provide you with a complete understanding of modern QA practices. They represent the essential knowledge needed to implement effective quality assurance in today's fast-paced development environments. Quality assurance planning and strategy development form the cornerstone of successful quality management in modern software development. This process is particularly crucial in DevOps environments, where rapid delivery must be balanced with maintaining high-quality standards. When defining QA objectives and goals, organizations must align them with both business objectives and technical capabilities. For instance, Amazon's QA strategy focuses on automated testing and continuous monitoring to support their frequent deployment model while maintaining high reliability. The identification of QA deliverables and quality criteria requires careful consideration of various stakeholders' needs. Companies like Google demonstrate this through their comprehensive quality criteria that cover not just functionality, but also performance, security, and user experience. Resource requirements and scheduling must account for the automated nature of modern QA processes. Microsoft's approach to QA planning includes substantial investment in automated testing infrastructure while maintaining flexible resource allocation for exploratory testing and quality oversight. Risk identification and mitigation strategies are crucial elements of QA planning. Netflix's chaos engineering practices exemplify how organizations can proactively identify and address potential quality risks through systematic testing and monitoring. Effective test planning and test case development are essential components of quality assurance in DevOps environments. This process requires a systematic approach to ensure comprehensive coverage while maintaining efficiency. Understanding project requirements and defining test objectives requires close collaboration between development and testing teams. Companies like Facebook demonstrate this through their integrated approach to test execution and defect tracking in modern DevOps environments require sophisticated processes that support rapid development while maintaining quality standards. This becomes particularly crucial as organizations move toward continuous deployment. The preparation of test environments and data must support both automated and manual testing needs. Companies like GitLab demonstrate this through their use of ephemeral test environments that can be quickly provisioned and torn down as needed for testing. Executing test cases in a DevOps context often involves a combination of automated and manual testing. Netflix's approach to test execution includes automated tests running in their continuous integration pipeline, supplemented by exploratory testing for new features. Defect tracking in modern development environments requires sophisticated tools and processes. Atlassian's Jira, for example, integrates defect tracking with development workflows, enabling teams to maintain visibility and control over quality issues throughout the development cycle. The prioritization and resolution of defects must align with deployment schedules and business priorities. Amazon's approach to defect management includes automated severity assessment and integration with their deployment pipeline to prevent critical issues from reaching production. Test automation has become a cornerstone of quality assurance in DevOps environments, enabling organizations to maintain quality while supporting rapid development and deployment cycles. Test automation's definition has evolved beyond simple script execution to encompass sophisticated frameworks and approaches. Google's test automation strategy, for example, includes unit tests, integration tests, and end-to-end tests that run automatically with each code change. The benefits of test automation are particularly evident in continuous integration environments. Facebook's automated testing infrastructure executes thousands of tests with each code change, providing rapid feedback to developers and maintaining quality standards. Modern test automation tools and frameworks provide powerful capabilities for different testing needs. Selenium, for instance, has become a standard tool for web application testing, while JUnit and PyTest support unit testing across various programming languages. The test automation lifecycle must be carefully managed to maintain effectiveness. Microsoft's approach to test automation includes regular review and maintenance of automated tests to ensure they remain valuable and relevant as applications evolve. Performance testing and load testing are critical aspects of quality assurance in modern applications, particularly in DevOps environments where rapid changes could impact system performance. Performance testing involves comprehensive evaluation of system behavior under various conditions. Companies like Amazon constantly perform performance testing to ensure their systems can handle millions of concurrent users while maintaining responsive service. Load testing simulates real-world usage patterns to verify system capabilities. Netflix's approach to load testing includes simulating streaming behavior across different devices and network conditions to ensure consistent service quality. Various performance testing techniques serve different purposes. Stress testing helps identify breaking points, endurance testing verifies long-term stability, and spike testing ensures systems can handle sudden load increases. For example, financial systems often conduct stress tests to verify their ability to handle market volatility. Modern performance testing tools provide sophisticated capabilities for simulating load and analyzing results. Apache JMeter and Gatling are widely used for performance testing, offering capabilities for creating realistic load scenarios and detailed performance analysis. Usability testing and accessibility testing have become increasingly critical components of quality assurance in modern software development. These practices ensure that applications are not only functional, but also user-friendly and accessible to all users. Usability testing evaluates how effectively users can interact with software applications. Organizations like Apple demonstrate the value of comprehensive usability testing through their intuitive interfaces that set industry standards. Their approach involves extensive user research, prototype testing, and iterative refinement based on user feedback. In the context of DevOps environments, usability testing must be integrated into the continuous delivery pipeline. Companies like Airbnb have developed sophisticated frameworks for automated usability testing that can identify potential issues before deployment. This includes analyzing user interaction patterns, measuring task completion rates, and evaluating navigation efficiency. The importance of usability testing in modern software development cannot be overstated. LinkedIn's approach to usability testing involves continuous monitoring of user behavior patterns and regular usability studies to ensure their platform remains intuitive and efficient as new features are deployed. Accessibility testing ensures that software applications are usable by individuals with various disabilities. This aspect of testing has become increasingly important as organizations recognize the need for inclusive design and compliance with accessibility standards. Key considerations for usability testing include creating comprehensive user personas that represent different user groups and scenarios. Microsoft's inclusive design principles demonstrate how organizations can integrate accessibility considerations throughout the development process. Their approach includes regular testing with users who have different abilities and needs. The Web Content Accessibility Guidelines, WCAG, provide a framework for accessibility testing. Organizations like Google have implemented automated accessibility testing tools that verify compliance with these guidelines as part of their continuous integration pipeline. This includes checking for proper semantic markup, keyboard navigation, screen reader compatibility, and appropriate color contrast. Modern accessibility testing tools enable organizations to identify and address potential barriers to access. Tools like Wave, Axe, and NVDA have become essential components of the quality assurance process, helping ensure that applications remain accessible as they evolve through continuous deployment cycles. Security testing and vulnerability assessments have become paramount in modern software development, particularly in DevOps environments where rapid deployment must be balanced with robust security measures. Security testing aims to identify and address potential vulnerabilities before they can be exploited. Organizations like PayPal demonstrate the importance of comprehensive security testing through their multi-layered approach, which includes automated security scans, penetration testing, and continuous monitoring for potential threats. Vulnerability assessments must be integrated into the continuous integration pipeline to ensure that security checks occur automatically with each code change. Amazon Web Services provides an excellent example of this approach, with automated security testing tools that scan for common vulnerabilities, configuration issues, and potential security risks. Common security testing techniques have evolved to address modern threat landscapes. For instance, financial institutions like J.P. Morgan Chase implement sophisticated security testing frameworks that include automated scanning for injection attacks, cross-site scripting vulnerabilities, and authentication weaknesses. These tests are executed continuously as part of their deployment pipeline. The integration of security tools like OWASP, ZAP, and Burp Suite into DevOps workflows enables organizations to maintain strong security postures while supporting rapid development cycles. Regular security assessments and automated security testing have become essential components of modern quality assurance practices. Continuous integration and continuous delivery have transformed quality assurance practices, enabling organizations to maintain high-quality standards while supporting rapid development and deployment cycles. The integration of quality assurance into CI/CD pipelines requires sophisticated automation and tooling. Netflix's approach to quality assurance demonstrates how organizations can implement automated testing at multiple stages of the deployment pipeline. Their practices include automated unit tests, integration tests, and performance tests that execute with each code change. Continuous integration practices have evolved to support rapid feedback cycles. Companies like GitLab showcase how organizations can implement efficient C processes that include automated building, testing, and quality checks. Their approach ensures that quality issues are identified and addressed early in the development cycle. Continuous delivery extends these practices to support reliable software deployment. Amazon's deployment pipeline includes automated quality gates that verify various aspects of software quality before allowing changes to proceed to production. This includes automated security scanning, performance testing, and compatibility checks. Modern CI/CD tools like Jenkins, GitLab's CI/CD, and CircleCI provide robust capabilities for implementing automated quality assurance processes. End of TEPS. These tools enable organizations to maintain consistent quality standards while supporting the rapid pace of modern software development. Risk-based testing has become increasingly important in modern software development, where organizations must optimize testing efforts while managing potential risks effectively. The fundamental principle of risk-based testing involves identifying and prioritizing testing efforts based on potential business impact and technical risks. Organizations like Microsoft demonstrate this approach through their risk assessment frameworks, which help teams focus testing efforts on areas that present the greatest potential for business disruption. Risk identification and analysis require careful consideration of various factors. Companies like Google implement sophisticated risk assessment processes that consider factors such as user impact, business criticality, and technical complexity when determining testing priorities. The implementation of risk-based testing in DevOps environments requires careful balance. Amazon's approach to risk-based testing includes automated risk assessment tools that help identify high-risk areas requiring additional testing coverage. This enables them to maintain efficient testing processes while ensuring adequate coverage of critical functionality. The benefits of risk-based testing are particularly evident in large-scale systems. Facebook's testing strategy demonstrates how organizations can effectively allocate testing resources by focusing on areas that present the greatest risk to system stability and user experience. As we move into advanced quality assurance topics, we'll explore sophisticated techniques and emerging trends that are shaping the future of software quality assurance. These advanced topics represent the cutting edge of quality assurance practices, incorporating new technologies and methodologies that enable organizations to maintain quality while supporting increasingly complex software systems. Our discussion will cover everything from sophisticated metrics and measurements to emerging trends in artificial intelligence and Internet of Things testing. These topics are particularly relevant for organizations implementing modern DevOps practices and seeking to optimize their quality assurance processes. The landscape of advanced quality assurance encompasses a broad range of sophisticated topics that are transforming how organizations approach software quality. We'll explore comprehensive approaches to test metrics, reporting, and management practices that enable organizations to make data-driven decisions about quality. This includes examining how companies like Google and Amazon implement sophisticated testing frameworks and metrics collection systems. We'll also delve into modern testing methodologies like Agile testing and DevOps practices, examining how organizations can effectively integrate quality assurance into rapid development cycles. This includes exploring shift-left testing practices and test-driven development approaches that help organizations maintain quality while supporting rapid delivery. Finally, we'll examine emerging trends in quality assurance, including the application of artificial intelligence to testing processes and new approaches to testing Internet of Things devices and blockchain applications. These advanced topics represent the future of quality assurance in modern software development. As we conclude our exploration of quality assurance processes and techniques, let's prepare for an interactive discussion about implementing these practices in your own organizations. I encourage you to consider how these various quality assurance processes and techniques might apply to your specific context. Think about the challenges you face in implementing effective quality assurance practices and how the approaches we've discussed might help address those challenges. Your questions and insights will help deepen our understanding of these topics and provide valuable perspectives on implementing quality assurance practices in different organizational contexts.